Welcome back to my channel Kishore Sir Ki Pathshala. We are doing structure of the atom 9 Cbse science. Last time we have done subatomic particles of an atom and Dalton's atomic theory. Let's see today the Thomson's model of an atom. So Thomson proposed the model of an atom to be similar to that of a Christmas pudding. Here you see, okay, a Christmas pudding is there. Okay, the electrons in a sphere of the positively charged pudding, right? See here, okay, it's positively charged. Okay, pudding is there. The electrons are embedded into this. The negatively charged, okay, electrons are embedded into this, right? We can also think of a, you can also think of a watermelon, right? You can think of a watermelon and you'll see that the positive charge in the atom is spread all over like the red edible part. Okay, the red edible part is nothing but my, see here, the reddish part is nothing but my, the positive part, right? Okay, and the electrons are spread into it. Let me put the electrons this way. See, so these are the electrons spread in the edible part, while the electrons are there in the watermelon. In the positively charged sphere, these electrons are there, right? Here you can see those electrons are there, okay, and the sphere is of a positive charge. So this is what Thomson model taught us. Now let's see what Thomson proposed. Okay, Thomson proposed that an atom consists of a positively charged sphere. Atom is nothing but it a positively charged sphere, right? It's a positively charged sphere, and electrons are embedded into this. The negative and the positive charge, that is the negative charge of the electron and the positive charge of the proton of the sphere, they balance each other, and what happens that it is a neutral. The overall charge is a neutral charge. Although the Thomson model explained that the atoms are electrically neutral, right? Atoms are electrically neutral. The result of this experiment carried out by other scientists could not be explained by this model, right? So they could not explain the model itself. Okay, that's the reason Thomson told us in negative electrons are embedded in the positive sphere, right? Now let's see further, okay, how things progressed. Then came the Rutherford model of an atom. Now the Rutherford, what he did? Rutherford, he took a gold foil, right? Rutherford took a gold foil and he bombarded that gold foil with the alpha particles, right? Alpha particles were made to fall on this thin foil. Now, why he selected gold? What is the reason the gold was selected? Now we know that gold is highly malleable, right? Okay, so what happens? The thin sheets can be drawn. He selected gold foil because he wanted a very thin layer, and as you know, the gold has the property of malleability, right? This gold foil was about 1,000 atoms thick. Okay, here you see like this. Alpha particles are doubly charged helium ions. Okay, since they have the mass of 4 daltons, the fast moving alpha particles have considerable amount of energy. So the energy is there, considerable amount of energy is there with the alpha particle. So now it was expected that alpha particle would be deflected, right, by the subatomic particles in the gold atom, right? See here, what we'll think is that if we bombard this with alpha particle, what will happen? It will be getting deflected, right? Since the alpha particle were much heavier, right, than the proton, he did not expect to see a large deflection. Okay, the expectation was there, but did not expect a large deflection as such. Then let's see how the Rutherford model of an atom he placed this concept. Alpha particle scattering experiment gave totally unexpected result. Let's see what are the results all about. Right. The following observations were made. Most of the fast moving alpha particle passed straight. Here you see it passed straight through this gold foil. Right. Some of the alpha particles were deflected by the foil by a small angle. See, a small angle were deflected. Okay. Surprisingly, one out of every 12,000 particle appeared to be rebound. Right. Rebound. It hit and it came back. Okay. So out of 12,000, right, one bombarded. Then let's talk about the great scientist Rutherford. He was born in the Spring Grove on 30th August 1871. He was known as the father of the nuclear physics. He is the famous for his work on radioactivity, right, and the discovery of the nucleus of an atom with the gold foil experiment. So he got the Nobel Prize for Chemistry in 1908. Right, a great scientist Rutherford is. Then reasoning behind the concept. Let's see the reasoning behind the Rutherford's concept. So what he thought about the experiment, what he did with the gold foil. Let a child stand in front of a wall with his eyes closed. So the eyes are closed of this child, right? So let him throw stones at the wall from a distance. So he has a stones and he's throwing stones on the wall. So what he will hear? He will hear a sound when the stone strikes the wall. Stone is striking the wall and he is hearing a sound. But if a blindfolded child were to hear, hear to throw stone on the barbed wire, right? Before that, if he threw 10 stones, then he will hear 10 sounds, right? Okay, but what will happen if this is a what I tell you is a barbed wire, right? If this is the barbed wire like this, okay, and he is throwing the stone, will you hear the sound 10 times when he is throwing the stone 10 times? What do you feel? So many times the stone can pass this barbed wire, right? Okay, most of the stones would not hit the fencing and no sound would be heard. This is because there are a lot of gaps is there in the fence which allows the stones to pass through them. Okay, so this is the reasoning behind this. Okay. Following a similar reasoning as that of the wall and the barbed wire, so Rutherford concluded that the alpha particle experiment, most of the space inside the atom is empty. So he said that most of the space is empty, right? Okay. Because most of the alpha particle they pass through the gold foil without getting deflected. See this, they pass through this gold foil, okay, without getting deflected, right? Very few particles were deflected from their path, indicating that the positive charge of the atom occupies a very little space, right? So very few deflections you have seen. A very small fraction of alpha particle deflected by 180-degree, indicating that all the positive charge and the mass of the gold atom were concentrated in a very small volume within an atom, right? So this was a take home message from Rutherford's model. Now on the basis of his experiment, Rutherford put forward a nuclear model of an atom which had the following features. Let us see what are the features. So there is a positively charged center. He is saying a positively charged center is there, okay, in an atom called as nucleus. Here you see it's a nucleus, what is there in the center, right? Nearly all the mass of an atom resides in the nucleus. So all the mass is in the nucleus, concentrated in the nucleus. The electrons, they revolve around the nucleus in a circular path. Here you see electrons are revolving in a circular path. The size of the nucleus is very small as compared to the size of atom. Here you see the size of the nucleus is very, very small as compared to the nucleus, as compared to the atom. Right, so this is my nucleus and this is my atom. See the size is comparatively very small. Right, so now let's see the drawbacks of Rutherford model, right, of the atom. Now you have seen he nicely told us that all the mass is concentrated in the center and the electrons are, they are revolving, okay, around the nucleus. Right, so this is what we have seen. Here you see the nucleus, the circular path, they revolve. Right, now what are the drawbacks, okay, which pull down this Rutherford models? Let's see one by one. So the electrons which were revolving in a circular orbit is not expected to be stable. Right, they are revolving and they are not expected to be stable. Why? Any particle in circular orbit would undergo acceleration. Now any particle which is now moving around, what will happen? It will gain acceleration. Right, it will gain acceleration, it will gain, and what will happen because of that? During acceleration, charged particle would radiate energy. It will give out energy, it will radiate energy. And what will happen? The electron which is revolving would lose energy. Subsequently, after some time, it will lose energy, and finally it will fall in the nucleus. All right, it is revolving and it is having the acceleration, and because it is having acceleration, it is giving out the radiation and is losing energy, and it is moving towards the nucleus. If this was the case, the atom should be highly unstable, right? Hence matter would not exist in the form that we know, right? So what will happen? Will it be a neutral charged? No. Okay. Why? Because the electron is finally moving into the nucleus, right? But we know that atoms are quite stable. So Rutherford was not able to make us understand, right, how this things is happening, right? Okay. So this was the drawback of Rutherford model of the atom. So student, I'm sure you have understood today's topic of Rutherford model of atom and Thomson's atomic model. So we'll be continuing with this. Thanks for watching my channel Kishore Sir Ki Pathshala. Kindly like, share and subscribe my channel.